Ready-made maths YouTube mathematics training. Teacher and teaching assistant training. Over the next few sessions, we're going to be looking at mental multiplication. Yesterday, we introduced all of the strategies that we're going to be looking at, and today is day 2, where we're going to be looking at the strategy of reordering the calculation. Reordering the calculation is basically the multiplication version of number bonds, where basically we rearrange the calculation so it can be done in a much easier way.
Good morning and welcome to today's mental multiplication training. This is the first of the shorter sessions that we're going to be doing on a range of different mental multiplication strategies. Hopefully by the end of these little sessions you'll have a repertoire that you'll be able to use for whichever type of multiplication you're given. Today we're looking initially at multiplying 3 numbers together. Now obviously we made this point in the introduction video yesterday that we do need the children, before they start being taught any of these strategies, to have a bank of multiplication facts at their disposal. So again, I am assuming within all these sessions that the children that I'm teaching this to, and obviously yourselves, know the majority of our facts from 1 times 1 up to 12 times 12. Again, we'll cover them as we're doing these sessions, but let's just assume that they're already known facts. So what I'm going to do today is just look at those 4 calculations to begin with. We can see the title, reordering. But without reordering, let's just imagine you're a child in year 5 and you're being faced with any of these calculations. I regularly go into year 5 and write things like these on the board and say to the children, okay, I'm going to give you 20 seconds. How long will it take you to work that out? And what I usually find children doing is going like 4 times 7 is 28, 28 multiplied by 5. So 5 20s are 100 and 5 8s are 40. And hopefully in 20 seconds, they might get there. Many of them do 28 multiplied by 5 as a column method. You then get to this one, 9 times 2 is 18, 18 times 6, and then we're into that whole idea of doing 6 10s and 6 8s if they've got the partition strategy, but again, most children go straight for a column method. So again, makes it a bit more complicated. 8 times 12, if we know it, 96, and then we're up to 96 multiplied by 5. Now there's many ways to do that calculation, but even if we are good at partitioning, 5 90s are 450 and 5 6s are 30. Add them together, 480. 6 10s are 60, 6 8s are 48. We get the answer 108. 3 times 9 is 27, and 27 multiplied by 6. Again, 6 times 20 is 120, and 6 times 7 is 42. Add them together, you get 162. Now what I've actually done is I've done a lot of mental partitioning there, doing the 6 10s and the 6 8s, the 6 20s and the 6 7s. Most children tend not to do that. They do the first bit, they get to 28, 18, 96 and 27, assuming they know the facts, and then it's usually into a column method or a grid method sometimes in order to do the next bits. Could they be made easier? Could we look at those calculations and not have to go that far? Could we do them a little bit quicker? What I'd like to do, obviously bearing the title in mind, is to look at each of those calculations, write them down on a piece of paper, and then reorder them. Can you reorder them so they're easier to do? I'm going to pause the video now and let's see if you could do that. So let's have a look. What I've done is deliberately left the answers in, so we know the answers from the previous questions. Let's have a look at this. A little bit like number bonds. Find numbers that go together to make a number bond. Well, let's find numbers that go together to make a much easier calculation. I'm not going to do 28. I'm not going to do 35. I'm going to put the 4 with the 5. So I'm kind of going to rewrite it as 4 times 5 times 7. Suddenly, 4 times 5 is 20. So I end up with 20 multiplied by 7. A much easier way to get to 140 than 28 times 5. The next one, 9 times 2 times 6. Am I going to start off with 18 times 6? Definitely not. I'm going to reorder it. I've got 2 options here, I think that will both work. I could start off with 6 times 2 times 9. That will actually give me 12 times 9 is 108, one of the table's facts. Or possibly even easier, I'll put the 9 with the 6. 9 multiplied by 6 and then multiplied by 2. 9 times 6 is 54. and 54 times 2 is 108. What I often find doing this particular strategy, if you've got a 5, put it with an even number. If you've got a 2, leave it till the end, because then you can just double whatever number you've come up with. So whatever those other two numbers happen to be, multiply them together and then just double up at the end. Let's look at the third one. 8 times 12 times 5. What did we say a minute ago? Let's not start with 8 times 12, we've got a 5. So let's, like a number bond, let's put the 5 with an even number. So again, there's two options that would both work here. I can put the 5 with the 8 and I end up with 5 times 8 times 12, which basically is 40 times 12, which is 480. My other option is to do 12 times 5 and then multiply that by 8. 12 times 5 is 60, and 60 times 8 is 480. Now again, I'm assuming all the way through that we know, because 8 times 6 is 48, 8 times 60 is 480. Obviously that would need covering first, because I know 7 times 2 is 14, I know 7 times 20 is 140. And again, we're going to be looking at that strategy as well as part of this work. That leaves me with the final one. How do I rearrange this one? Well, I think this one's a little bit more complicated than the previous three. This one's got a 5 that can go with the 4. This one's got a 2 that can double at the end. This one's got a 5 that can go with the 12 or the 8. This one, I've got kind of 3 options. So I'm going to show you all 3 options. Put a little line going across here for a minute. 9 times 3 is 27, and that's 27 times 6. I could start off with 9 times 6 is 54, and multiply that by 3. Or I could do 6 times 3 is 18, and multiply that by 9. So again, with that particular one, it's kind of which of those do you prefer? And that's the sort of activity I like to ask the children when they get to this point in year 5 and 6. You've got 3 options there, which is easier? Personally, I think this one, the middle one, is easier. 50 times 3 is 150, and 4 times 3 is 12. 150 and 12 is 162. Linked to another strategy later in the week though, 18 times 9. Well, I know 9 times 9 is 81, so if I double it, I'll get to 162. So there's various other strategies that we can build in at that point. But the main point of today is to look at the calculation and just think, right, I can reorder them any way I want to make it easier to calculate. What we're going to do now is I'm going to basically just pause the video for a second while you have a look at what we've just done there, and I'm going to rewrite a different set of calculations to look at.
Now, having seen quite a few examples in the ready-made maths classroom, what I'd like us to do now is to get some pencil and paper out, or a whiteboard and pen, or something to jot on, and have a little go at the 4 examples that we've got here. As we've mentioned, there are 3 ways to do each example. What we're looking for is the easiest way. The easiest way to manipulate those numbers to reorder the calculation so we can get the answer much easier. So if we pause the video now, have a look at those, jot them down, and then we'll come back and have a look at some potential ways to do it. Now, as we can see with the first one, apart from the 16 multiplied by 6, which is the way that it's set out, either of the other options would work. We could start with the 8 times 6, that gives us 48, and we could double it, which gives us the answer 96, or probably even easier, we put the 6 multiplied by 2 together, that gives us 12, and 12 times 8 is one of our tables facts. 12 times 8 is 96. So 2 ways to do that one, both of which are relatively simple. The next one, I hope, was a little bit more obvious. We've got a 7, a 6, and a 5. That strategy of, well, if we've got a 5, one really good thing to do is to put it with an even number. So we end up with a multiple of 10. So 6 multiplied by 5 gives us 30. We multiply that by 7, and we get the product, 210. The next one, again, that strategy of leave the 2 till the end, multiply by 2 at the end to double it. Let's try that one out. So we put the 12 and the 7 together. 12 times 7 gives us a product of 84. We multiply that by 2, and we get an overall product of 168. The last one, again, we've got an 8 and we've got a 5. So let's get those numbers together. 8 times 5, that's going to give us 40. We multiply that by 11. Again, we know 11 times 4 is 44. So 11 times 40 is 440. So hopefully none of those were too difficult. They've got both of those little things we looked at before. They're putting the 5 with an even number, and they're leaving the 2 till the end so that we can double it. Remembering though, if we get a 5 and a 2 together, well, let's put them together because that will give us a 10. This is the visual calculation policy from Sense of Number, which does a very similar thing. What I quite like about the 3 examples you can see here, we'll give you time to have a look at them, is that it suggests that as an activity in a lesson, what you could do is ask the children to actually write out all 3 options and then choose the favourite. So as you can see here, we've got 18 multiplied by 5, 9 times 2, 45 doubled, or 10 multiplied by 9. Now, although double 45 is quite easy, I think we can all agree that 10 times 9 is the easiest of the 3. Moving over here, we can see 7 times 4 times 5, 7 times 5 times 4, and 4 times 5 times 7. And again, it's that last one, I think, which is the easiest of the 3, 20 multiplied by 7. The third example actually leaves it open to interpretation. 3 quite nasty numbers. 9 times 8 is 72. We multiply that by 6. 9 times 6 is 54. We multiply that by 8. Or 8 times 6 is 48. We multiply that by 9. Looking at the 3, I definitely thought that was the easiest of the 3 because 8 50s are 400 and 8 4s are 32. So you've got no complicated calculations to work on. But again, let the children practice all 3 of them, put them all down, and then make that sensible decision, which is the easiest one to start with. And here's the example that we looked at yesterday in the first training video. 8 multiplied by 9 multiplied by 25. Looking at the 3 options there, I certainly don't fancy 72 times 25. 225 times 8 might be a little bit easier, 8 200s and 8 25s. But I think 200 multiplied by 9 is definitely the easiest of those 3 options. So again, if you've got a number like 25, put that with an even number, and a similar principle applies. So, it's worth trying a lot of different examples as children move into years 5 and 6. By year 6, if you're on a really developed mental mathematics skills, let the children have a go at these. So again, pause the video, have a look, and see which way you would approach each of these. Let's have a look then. I think with the first one, I think hopefully straight away we'll see, well, it's not a 2, it's a 20, but 5 20s give me 100. Multiply that by my 11, I've got 1,100, 1,100. That other example underneath, a little bit like the one we've just looked at, we've got a 25 and we've got a 4. Let's immediately put those together, and that gives us 100 multiplied by 9. Again, hopefully relatively easy to see. Similar, we've still got that 5 in there, it's 15 tens, 150. So if I've got 150, well, I'd much rather have 4 150s than 7 150s or 28 150s. So what I'll do is I'll put the 150 multiplied by 4 together. 150 doubled is 300, doubled again is 600. 600 multiplied by 7. Now we know 7 times 6 is 42. 7 times 60 is 420. So 7 times 600 is 4,200. So again, it looks complicated, but relatively easy if we manipulate the numbers and reorder them. This is where a lot of children would look at this and go, wow, that's really hard. 3.5 times 9 times 2. Not if you start with 3.5 times 2. Double 3.5 is 7, and 7 9s are 63. Something that looks so complicated can be done so much easier. Certainly more easier than 9 times 2 times 3.5, or even harder, 3.5 times 9 times 2. That brings me to the final one. If I keep these in the order that they're currently in, I'm going to have, go 15 3/4 times 4. So I'm certainly going to try and change that. I'm going to put the 2.25 with the 4. This is a little bit harder, but 4 times 2 is 8, and 4 times 1/4 is 1, so that gives you 9. So 2.25 times 4 is 9. You might need to do a jot in there, and then 9 times 7 again is 63. Now, I know we've gone through those fairly quickly, but you can pause the video at any time, have a look at them, think about the multiplication, but just look how easy we've actually made that calculation that on the surface looks like an absolute horror, can be done as long as we put the numbers and reorder them using that commutative rule.
Let's have a look at the board now. It now looks even more complex. We've now got 4 numbers to multiply together. 4 times 6 times 2 times 3, 7 times 2 times 9 times 5, and 8 times 3 times 25 times 7. Can I manage to find a way to rearrange or reorder those calculations to make them easier. So again, let's pause the video, get your pen and paper out, have a discussion if you've got somebody else to talk to, and just have a see, can you rearrange those? There's many ways to do it, but which are the easiest ways? Then you can answer the calculations quite quickly. Let's go. With the first one, there are probably numerous ways we can change this. We could put the 4 with the 3. That gives us 12. We could do 12 times 6 is 72. So I could rewrite it as 4 times 3 times 6 times 2. If I do it that way, 4 times 3 is 12. Again, in our known facts, 12 times 6 is 72. And then we double up to get 144. Obviously, there are other ways. What I could also do, interested in looking at that, is I could just put the 4 times 3 together and the 6 times 2 together. 4 times 3 is 12 and 6 times 2 is 12. And again, that gives us 12 times 12, which is 144. There's many ways with that because the numbers are fairly small. We could do 3 times 2 is 6, 6 times 6 is 36, and then double it twice, 72, 144. So that one, as long as we don't start off with the 24, it's relatively easy to reorder it. What about the next one? Well, we've actually got, I kind of gave the advice to leave the 2 till the end to double, but not in this instance. What can we see here straight away? We've got a 5 and we've got a 2. So definitely I'm going to put my 5 with my 2. I might leave that till the end. So I'm going to do 7 times 9 and then I've got times 5 times 2. So again, 7 times 9 is 63 if I kind of put brackets around them, and 5 times 2 is 10. So 63 times 10 equals 630. If children want to do the whole thing in order, well, 5 times 2 is 10, 10 times 9 is 90, and 90 times 7 is 630. But again, I quite like the idea of doing the brackets and getting that into the calculation as well. Right, the third one. What are we going to do with that one? Well, with that one, we kind of only see, there's probably many ways to do it. I could put the 25 with the 3 to make 75, but that's not as easy a number to deal with. 7 times 3 is 21. That's not going to be too easy, but I've got an 8 and I've got a 25. Now this obviously is at year 6 level now. We're thinking, well, I know that 4 25s are 100. Therefore, 8 25s are 200. So I'm going to start off with that. So I'm going to do 25. I'm going to multiply that by 8. I'm then going to multiply it by 3. And I'm then going to multiply it by 7. Let's see how that works. I'm not going to use brackets this time. 25 multiplied by 8 gives me 200. 200 multiplied by 3 gives me 600. And 600 multiplied by 7. I could even rewrite it each time just to show what's going on. So 25 times 8 is 200. 200 times 3 is 600. 600 times 7 is 4,200. So again, that's a year 6 calculation, but just by reordering it. Otherwise, we're starting with 24 times 25 times 7. That's going to take an awful long time. So let's focus in on the board now and let's have a look why this is such a useful strategy. It's all about commutativity. Commutativity is that rule of maths which basically shows, and we're going to prove it later in the week, that whichever way you multiply numbers, the product always remains the same. In exactly the same way, whenever you add numbers, if I was to add 7, 2, 9 and 5, doesn't matter which order I do it in, the total is always going to be the same. It's going to be 23, whichever way I add it. So for addition and for multiplication, which is repeated addition, we've got that rule of commutativity. So rearrange them, reorder them, and make the calculation as easy as we can.
Now, having briefly looked at some examples back in the classroom with 4 numbers, let's again take some time to try these out. Don't worry, this takes quite a while. It's just a matter of playing with the numbers. And with these, there are definitely several ways that you can get the answer. There's no real right way of doing it. Looking at that first one, I can immediately see potentially 3 ways of manipulating those numbers in order to make the calculation work. So have a play, just see if you can find what you think is the best way to multiply those numbers together. Now, as you'll notice with the first one, we do have a 5 and we have 3 even numbers. So I have got that potential of putting the 8 times 5 is 40, the 5 times 2 is 10, or the 5 times 6 is 30. Any of them will work quite quickly. The example I've gone for is to actually put the 8 multiplied by 5 to give me 40, and then the 6 multiplied by 2 will give me 12. 40 times 12 is 480. But if I just have gone for 5 times 8 is 40, doubled it is 80, times it by 6 would have worked. If I've gone for 5 times 2 is 10, and 8 times 6 is 48, we'd have had 48 times 10. And if I'd have gone for 5 times 6 is 30, and doubled it was 60, and times 8, I'd still get 480. So with those, there are lots and lots of easy ways. The next one I do think is a little bit more obvious which two numbers need to go together at some point, and that's the 6 and the 5, because that's going to give me a 30. Let's have a look. So we'll put those together to begin with. So 6 multiplied by 5 will give me 30. Then I'll times that by the 7. That gives me 210. And finally, I'll multiply by 3. 3 times 200 is 600. 3 times 10 is 30. The next one, again, entirely up to you how you'd like to do this one. There was the idea before of leaving the 2 till the end and doubling. But I've actually gone for an alternative approach on this one. Let's have a look. I've started with the 9 times 6. Let's get the two biggest numbers out of the way and get to 54. And then I've gone for the double. 54 doubled is 108, because that gave me quite an easy way to finish. 3 hundreds and 3 8s. If I'd have gone the other way, it would have been 54 times 3, which is a bit trickier, and then double it. So 54 times 3 would have been 162, which would have to be doubled. So I thought this way was a little bit easier. The final one, again, we've got two options, I think, here. The 15 can go with the 2 to make 30, or with the 4 to make 60. I decided to go with 15 times 2. That made me 30. I times that by 7, which gave me 210, and I multiplied that by 4. If I'd have started with the 15 times 4, that would have been 60, times 7, 420, and doubled, 840. So as you can see, there's always lots of options, but I'm certainly not going to be starting off with 28 times 15, or 18 times 6, or 18 times 7, and so on. I'm going to be looking for a way to reorder and make it much easier. What we're going to do now is we're going to revisit a game that we played a few weeks ago when we did the mental edition, and that game was digit card turnover. We played a few different variations of it. We're just going to play a very simple one. I've got 3 mixed up packs of digit cards. I've removed the 1s and the 0s because I don't want to multiply by 1 or 0. Once we've got over the fact that multiplying by 1 keeps the same answer and multiplying by 0 gives us 0, I've just left in all of the other cards. So we've got the digits 2 to 9. We've left out 11 and 12 for the time being, but again, I'm going to bring those in shortly. So I'm going to turn over the first 3 cards. I've got a 7 multiplied by a 3 multiplied by an 8. Now actually, that's not a particularly easy one. We'll come to that one in a minute. I'll leave that one there for you to be having a look at. The next set, we've got a 3 multiplied by a 9 multiplied by a 6. Again, it's not being very nice to us with these ones. We've got a 9 again, multiplied by 5, multiplied by 6. I think that one's a little bit easier. I'm going to move these a little bit. I'm going to put 5 of these out for you to look at. I'm going to take an 8, a 2, and a 7. Again, I think that one's relatively straightforward. And I'm going to put a 7, a 6, and a 2. Now, I think this sort of game is so easy to play in class. It's also very easy to play at home. If you've got children that need multiplication practice at home, this is a really easy one to play. You can easily get cards and write out cards from 0 to 9, turn them over. In fact, you could even do cards from 2 up to 12 and do it that way. So I'm going to ask you now to pause the video to look at all 5 calculations, and can you find the easiest way to reorder them in order to get the correct answer? Off you go. What I'm going to do is actually start with the calculation down at the bottom there. 7 multiplied by 6 multiplied by 2. Now what's lovely about the cards is you can manipulate them and reorder them, so I can move them around and put them anywhere that I want. Now what I would probably do with that one actually is leave them exactly where they are. 7 times 6, 42, doubled is 84. But actually some children might do it that way around. 6 2 to 12, 12 7s are 84. The one that I probably wouldn't do is 2 multiplied by 7 is 14, and 14 times 6. The answer will be the same, but let's find the easiest way. And for me, the easiest way is double 42. Now, the next one I'm definitely not leaving in that place. I certainly don't want 16 multiplied by 7, nor do I want 14 multiplied by 8. What I'd definitely like for this one is 56 doubled. 8 7s are 56, doubled is 112. As I move to the next one, do I want 45 multiplied by 6? That's not too hard, but probably not. Do I want 54 multiplied by 5? Again, not too difficult, but I think I can see an easier way. What I want to do with this one
is put the 6 and the 5 together. 6 times 5 is 30, and 30 times 9. Well, I know 3 times 9 is 27, so 30 times 9 is 270. So I think those three are quite easy. These ones, even at year 5, are getting a little bit more complicated. So what I'm going to do with these, I'm going to write down the 3 different options for each. So I'm going to take a little mini whiteboard, I'm going to write down the 3 options. 7 times 3 times 8 will give me 21 times 8. I'm going to swap round now, I'm going to make it 8 times 3 times 7, which will be 24 times 7. Or I can do 8 times 7 times 3, which will be 56 times 3. That's worth doing, and it's worth asking the children to do as well. Just write down all the 3 options. It's just a mental arithmetic game. Which of those is easier? Again, I'd probably not go for that one. That one's not so bad. 168, or 3 times 50 is 150, and 3 times 6 is 18. But unless the children have practiced the partitioning strategy, which we're going to be looking at tomorrow, then obviously they're straight into column method at this point. So let's make sure before we start to do this activity that partitioning is really secure as well. The next one, we've got 3 times 9 times 6. So I'll keep that one as it is. So that's 27 multiplied by 6. I'll then put the 6 there, which gives me 6 times 9 times 3, which is 54 multiplied by 3. And finally, 6 times 3 times 9, which gives me 18 multiplied by 9. Now again, as to which you prefer, I think if you're partitioning, it doesn't really matter. 120, add 42, 150, add 12. I would probably go for the middle one. 3 times 50 is 150, and 3 times 4 is 12. That will give me 162. Or I can use a different strategy here. 9 times 9 is 18. 9 times 9 is not 18. 9 times 9 is 81. If I double that, I'll get 18 times 9, 162. That's another strategy we're looking at later in the week. But I think for this purpose, I'm going to go for this one. 3 50s are 150, 3 4s are 12, and that gives me 162. Games, it is always worth having something to jot on. I'm not asking the children to hold the whole thing in their head. I'm definitely going to say, as I did with addition, if they want to jot things down, jot the little stages, jot the partition, that's absolutely great. That's still working on mental arithmetic. So I'm encouraging jottings until everything can be, held in their head. So children at year 4 and 5, starting on that strategy, let's make sure they've got that facility of jotting first of all. The other thing to do is to build it up. Now what I could do is turn over 4 cards. 3 times 7 times 3 times 9. I'll get 4 different numbers. 3 times 7 times 6 times 9, and try the same idea. Now I could do that with cards, or if I want to include 1 to 12, I could develop it into a dice game. So what I'm going to do now is I'm going to take some dodecahedrons, some 12 faced dice. I'm going to roll each of these. I'm going to start off with 3 of them. And I've rolled the 5, the 12 and the 2. And again, what's lovely about this is you can just put them in order. So again, I'm going to put the 5 with the 2. 5 times 2 is 10. And either way around, 10 times 12 is 120. Very, very straightforward. What I'm going to do now then is roll some dice. I'm going to roll 4 dice. Put them on the table. What I'm going to do now is put those numbers together. I've got a 1, an 11, a 5, and a 4. I'm going to roll that 1 again. Okay, there we go. Brilliant. So I've got 11, 4, 5, and 4. What I'd like to do is just look at those and decide what's going to be the easiest way to multiply those numbers. I've now rearranged those numbers, and I think that's probably the easiest way. Let's go in order. 5 times 4 is 20. 20 times 4 is 80. And then 11 times 80 is 880. Let's just try one more set of numbers. So I've rolled 4 numbers there. I've rolled a 5, a 9, an 8, and another 5. So there's going to be a few different ways, I think, of making that one work. I probably won't be starting with 5 times 9 is 45. So let me just home in on that. Have a look at those, write them down, rearrange them, do any jottings you want. How quickly can you work the answer out to that one? Possibly you went for this one. 8 times 5 is 40. 5 40s are 200. And 200 times 9 is 1,800. Maybe, as an alternative, you put the 5 5s together. 5 5s are 25, and then 8 25s. We looked at that one earlier. 8 25s are 200, and again, 200 times 9 is 1,800.
And here are the final examples that I'd like you to look at. With these ones, there are 5 numbers to multiply together. With these, I'm just going to let you have a look at them. I'll then put the answers up. I won't go through the answers in detail. What I'd like you to do then is just have a look at them yourself and see if you can work out the way that I've put them together. Again, I'm not saying that my way is the right way to do it. There's many ways that you can put these together. As you can see, with a number like 7.5, that can multiply by 4 or 2. If you've got a quarter and a half here, they can go with the 4 or the 12. So 12 halves are 6, and 4 quarters are 1, or 4 halves are 2, and 12 quarters are 3. So you've got different ways in which you can do that. You've got down here a 2.5 and a 1.5, which again, 2.5, 1.5 can be multiplied with the 6 or the 4. So there's again lots and lots of options that you might wish to use. So have a look at these, and then I'll just put the answers up and let you have a look through them in your own time. And so here are some possible answers that you might wish to use. I've colour-coded that one with brackets to make it a little bit easier. Relatively straightforward when you look at the way it's been done. Again, brackets again, the 7.5 with the 2 and the 4 with the 5. This one, I just thought we had to put the quarter with the 4, 0.25 with the 4. That probably gave us the easiest calculation of the lot. And with this one, we put the 1.5 with the 6 and the 2.5 with the 4 again, because that gave us a 10. I could have put the 2.5 with the 6 and the 1.5 with the 4. But I thought that was the easiest way to do it. As you can see, we'll start off looking like really complex calculations, especially if we do them in order. 12 times 9 is 108 times 4 times a half times a quarter, or 12 times 7.5, or that one's not so bad. That one's actually quite easy, 40, 120, and so on, but still there's easier ways to do it. And this last one, done in order, will be an absolute nightmare. So as I say, the whole point of reorder is to find the easiest way to do it.
So I hope you've enjoyed the first of our mental arithmetic multiplication sessions. Obviously, this is operating at years 4 and definitely at years 5 and 6. And as we said right at the start, we've got to have secured tables facts first. But if we are operating at year 5, 6, obviously the expectation nationally is that by the end of year 4, most children have got most table facts learned. So fingers crossed we're in that situation. If we're not, obviously, that needs to come first. I deliberately started with that one because it is single-digit numbers. Although we do end up with 2-digit numbers and we do end up with slightly more complicated things, I wanted to make sure that was the first thing we got in our head, that I can always move them around. And again, let's make sure children know that. I can always manipulate them so I can change the order and find an easier way to do it. The rest of the sessions, obviously, we're going to go into specific individual strategies. And then at the end, we'll come back to that and we'll apply all the strategies that we've learned to the same sort of game. So I hope you've enjoyed the session today. I look forward to seeing you tomorrow, where we're going to be looking at partitioning.
That's it for today. I know towards the end we did get some quite complicated examples, but that is the point of this particular training, these next few sessions. We're going to look at visuals, we're going to look at easier examples, and we're going to build them up so that by year 5, 6, the children have got strategies that they can use all of the time with slightly more complicated numbers. It's just something that will always work. So reordering today, tomorrow we're moving on to partitioning, which is probably the default strategy for most 2 digits by 1 digit multiplications. I look forward to seeing you then. Thank you very much, and I'll see you.